In the last video we studied about implicit differentiation, and today we're going to prove that if we derive the explicit form of an implicit function and then find the derivative of it, you're going to get the same solution. So in the last video we had the expression x squared plus y squared, the square root of that, plus x squared is equal to 2. And through implicit differentiation we found that dy over dx is equal to minus 2x times the square root of x squared plus y squared minus x over y. And today we're going to prove that if we express y in terms of x and then find the derivative dy with respect to x, we're going to get the same equation as this. Okay, so here I have done that. We see that here is the equation: the square root of x squared plus y squared plus x squared is equal to 2. And then what I've done is I've moved the x squared to the other side of the equal sign, and then I squared both sides of the equation, and then I moved the x squared to the right side of the equation. And when we expand the squared equation, we'll get that y squared is equal to 4 minus 5 times the x squared plus x to the 4th power. And we'll get for y that is the plus minus of the square root of 4 minus 5 times x squared plus x to the 4th power. And then what I've done is I've written both solutions separately, and then I found the derivatives of both equations. Here we only applied the chain rule, and what we'll get for the derivatives of these two expressions is basically the same thing, only the expression on the right is multiplied times minus 1. Okay, so here we have the previous equation, the equation that we've proved from the last video. And what we were going to do in this video is basically prove that these two are equal. So let's rewrite, let's move this to the side, and then we're going to rewrite the equation. So the square root of x squared plus y squared plus x squared is equal to 2. And the derivative through implicit differentiation was equal to y, and in the numerator we had minus 2x times the square root of x squared plus y squared minus x. And here are the solutions of this equation. Y is equal to plus minus the square root of 4 minus 5 x squared plus x squared. Okay, and now I'm going to calculate this separately. On this side I'm going to replace y with the positive square root of y, and on the right side I'm going to replace y with the negative square root. And we will see what we're going to get for this solution. So let's just replace y with the positive root, so we'll get 4 minus 5x squared plus x to the 4th power minus 2x, then x squared plus 4 minus 5x squared plus x to the 4th power minus x. Okay, so we can simplify things a little bit, and we'll get the same thing in the denominator. And in the numerator, here we can actually calculate. We'll get in the square root, let's see, 4 minus 4x squared plus x to the 4th power minus x, and this is basically we can rewrite this expression as minus 2x as, let's see, 2 minus 2x squared, and then if we find the square root of that, we will remove the exponent. Minus x is equal to 4 minus 5x squared plus x to the 4th power. And then finally, if we calculate this, we'll get that it is equal to, let's see, minus 5x, if we account this x, times plus 4, and we get basically the same thing as in this equation here. Only here, if we divide the numerator by 2, we will get the same equation as here. That is, if we replace the equation that we got through implicit differentiation with the positive square root of y. And in the next video, I'm going to replace y with the negative square root, and then we're going to look at the graph of this equation and see why the differentiation through explicit and implicit forms is basically equal.